Welcome everybody to Algebra 1, Section 6.1, Solving Systems of Equations by Graphing. So let's first start by defining what a systems of equation is, and that's a set of two or more equations with two or more variables. And the solution to a system is found either graphically, which we'll cover today, or algebraically, which we'll cover in sections 2 and 3. So graphically, it's the point where the two lines, because whenever you have two linear equations, you have two lines, and it's where these two lines intersect, touch, cross, or meet, however you want to think of it. The mathematical word, once again, is intersect. We also think of it as touching, crossing, or meeting. And algebraically, it's the point where that makes both equations true. And it's the same value, or in this case, ordered pair for a system of equations is an ordered pair. And it's the same ordered pair regardless of whether you find it graphically or algebraically. So we have three types of solutions. One is if the lines intersect some way, somehow. And so a picture of that is just two lines intersecting. And that means you have one solution, which is the ordered pair, and some ordered pair x comma y, where you have an x value and a y value on the coordinate plane. A second scenario is where you have two parallel lines. And when you have two parallel lines, that means they never intersect. Well, if we said the solution is where they intersect, that means there's no solution, which you can abbreviate to NO for no, or I guess that's not an abbreviation. You can abbreviate solution to SOL, period. And then our third scenario is if they're the same exact line. So I'll just kind of showcase this here, that if you draw one line on top of the other, essentially, it's not like one line shorter, the arrows mean they both go forever, that you have infinitely many solutions, or IMS, because they intersect every single place on the line. They have infinitely many intersections because they technically have a bunch of little points all along here where they intersect everywhere. And so in order to solve a system of equations by graphing, we have to follow a few steps, and it boils down essentially to graphing both lines. And so step one is to rewrite the equations in slope-intercept form. Quick reminder for everybody, slope-intercept form is y equals mx plus b. The second step is to graph the lines. And then the third step is to identify the solutions. Or solution, or solutions, depending on if it's infinitely many solutions. So that S would be in parentheses saying sometimes it's singular, sometimes it's plural. So let's jump into it. So directions, solve the system of equations by graphing. So we have this notation, or how it's written, where this tells us it's a system. It tells us it's a set of two equations that go together. And so we have one equation and our other equation. And each equation here is actually already solved for slope-intercept form. It's already in the y equals mx plus b, y equals everything else. So we're going to go ahead and start by identifying the slope and the y-intercept and graphing these. So this first one has a slope of 1, because it's secretly a 1x, and a b, or y-intercept, of -8. And as you may recall, we begin graphing with our y-intercept, or as I like to say, we begin with b. And the y-intercept is where it crosses the y-axis. So if it crosses the y-axis at -8, that means we need to go down 8. Heads up, this graph goes 10 up, 10 down, 10 to the left, and 10 to the right. And so now my slope of positive 1, or positive 1 over 1, would go up 1, right 1, or down 1, left 1 the whole way. And I'm just going to continually go, and the reason I'm going to continually go is because I know eventually where these are going to intersect anyway, and that I want these to have straight lines to do so. So I encourage you to either make multiple points like I did, so you can connect them and ensure your line is going to be straighter, or use some sort of straight edge, such as a ruler or the edge of a binder or notebook, so that way your line will be straight. I'll explain more in depth after I finish this problem. So the second equation, which I'm going to graph in blue here, The slope is -2 or -2/1. Remember, this fractions are always, numbers are always a fraction. You can always just put something over 1 if you don't see the denominator. And the b on this other one is 1. So I'm going to begin with b by going up 1 because it's positive 1. And now since it's a -2/1, the slope is negative. It's going to go downhill from left to right. And so you can either go up to left 1 or down to right 1. And since I'm trying to figure out where they intersect, I don't really need to make more points up and to the left, but I do need to make more points down and to the right to see where they intersect. And I can now see, hey, these are going to intersect right here at this purple dot that I just made. And that would be the ordered pair 3, -5. And that's where they intersect. Now, once again, I mentioned how we want to use either a straight edge or a lot of points to make sure our lines are straight. And you may already noticed why that might be the case. And if you haven't noticed yet, well, let me show. If I were to just be slightly off with this green line, instead of, let's say I got slightly off the blue line and I made this green line instead, then all of a sudden my intersection is slightly different. And so we need to make sure that we're being accurate with our lines and making sure they're very straight, so that way we are getting the accurate answer, since we're visually seeing where the two different things cross, two different lines intersect. I do want to mention that you're always able to check your work as well algebraically. How you can check your work is very similar to equations, where you plug in your answer to see if it worked. So what you would do is you would say this is an x, this is a y for my ordered pair, x comma y, and then you plug it into your equations one at a time. So if I were to plug this into my first equation here, I would say I would have 5 equals 3 minus 8. And I ask myself, is this true? I replace the y with the 5, which is what I got for my y value. I replace the x with the 3, which is what I got for my x value. And I do verify that, or my apologies, -5 is my y value. I said 5. And so -5 does in fact equal -5, which is 3 minus 8, so it works. However, since it's a system of two equations, not just a singular equation, I have to verify that it works for both equations. And so I plug it into y equals -2x plus 1 as well, and I get -5 instead of y equals -2 times 3 instead of -2 times x plus 1. And it's -5 equals -6 plus 1, which is in fact -5 equals -5, and this does verify to be accurate. And so because it worked in both equations, it is the solution. If it were to work in only one equation or neither equation, that means we did something wrong and it's not actually the solution. Now, I'm not going to require that you check your work on these, but it is always an option available to you. Moving on to number 2. Number 2, these are again solved already for slope-intercept form. I'm going to encourage you to try graphing these on your own and pausing this video to do so, and then resuming the video once you are done with either one or both lines graphing. But I'm going to go ahead and graph this top line now. So I'm going to do the top one in orange again, and I'll have M. Maybe it'll let me draw an M. It's not too happy with my desire to draw an M right now. There we go. Equals 1/2, and the B equals 9. So I'm going to go up 9. I'm either going to go up 1, right 2, or down 1, left 2. And make my straight line. Then I'll graph this other one. I'll do it in blue again. I get -1 or -1/1, and my B of 6. And I either go down 1, right 1, or up 1, left 1. And I notice that these intersect right here at the purple point I made, which is -2, 8. And so we write our answer as an ordered pair, and we call it good. Moving on to number 3. Here, these are not solved for slope-intercept form. So I have to solve each of these for slope-intercept form by getting y by itself. So if you want to try this on your own, go ahead and pause the video, but otherwise go ahead and keep watching and watch how I solve these for y. So this top equation, y is being added with the -3x. I can do that by adding 3x to both sides. And I get y equals, I can't combine 8 with 3x, but I do want to write the 3x first before the 8, as I just write them next to each other. because it goes y equals mx plus b. And so now I can establish that the slope here is 3, or 3 over 1, and the b is 8. So I can go ahead and graph that. And you could either choose to graph this one right now, or wait until after you solve the other equation and then graph them both at the same time. It's really up to you. So I go up 8, and then I can either go up 3 right 1, which takes me off the graph, or I can go down 3 left 1. Oh, I must have thought I wanted a curve there. Must have drawn it poorly enough. All right, so now as I solve the other one, y is being added with a negative x, so I'm going to do that by adding x. And I get, it zoomed out on me for some reason while I did that, y equals positive x minus 2, where my slope is 1 over 1, and my b is negative 2. So I'm going to begin by going down 2, and I can either go up 1 right 1, or down 1 left 1. And now I can notice my intersection is the ordered pair right here, -5, -7. Moving on to number 4, once again I need to solve the equation for slope-intercept form for y, but the second one's already solved. How convenient. So I start solving this top equation. I'm going to start by subtracting x, and I'm going to get -x, let me try it again, 2y equals -x plus 4, but now y is not quite yet by itself still, so I need to go ahead and divide everything by 2 to undo multiplication, and I get y equals -1/2 x plus 2. Remember, this is secretly a -1x, and -1 divided by 2 is just -1/2. So now I can establish that my slope here is -1/2, and my y-intercept is 2. So I'm going to go ahead and graph that by beginning at my b, and I either go up 1 left 2 or down 1 right 2 to go downhill from left to right. As I go and establish my next one, I notice my slope is -1/2 and my b is 2. And as I graph this, I notice, hey, wait a second, those are quite familiar because it's the exact same. And that means that these are the same line, which means that the solution is infinitely many solutions. It's all solutions. Any point on this line, not all solutions I should note, but it's any point on the line. And these are exactly the same line. Now, you could have noticed, perhaps, that these were the same line before even graphing it, because they're the same exact equation. The slopes were the same, and the y-intercepts were the same. Number 5. As I solve this first equation for slope-intercept form, solving it for y, I'm going to start by subtracting x. And I get 3y equals -x minus 15. I divide every single thing by 3. And I get, as I move over here, y equals -1/3 x minus 5, which establishes my slope to be -1/3 and my y-intercept to be -5. And this time I suppose I'm going to use green here. And so I go ahead and graph my points. Make my line and call it good. And as I go to graph my other line, I notice, hey, wait a second, actually. This is already solved for slope-intercept form, but more specifically, it's y equals a number. Well, two ways you can think about it. One is that this is secretly a 0x minus 7, since there's no x showing there. It's 0 minus 7. And so a slope of 0 means it's going perfectly horizontal left and right only, no up and down, no rise at all. You can also remember that horizontal lines, y equals a number, are always produce a horizontal line. Just like x equals a number is always a vertical line. So I go to where y equals negative 7. I say y is negative 7 here. It's also negative 7 anywhere on this line. And so I could just keep making points, for example, as far as where to make my line. But the one point I need now at this time is where they intersect. And that's the ordered pair 6, negative 7. Looking at number 6, the first equation is already solved. Good for me. So I'm going to make my slope as 1 over 1. My b is 5, and I'm going to go ahead and graph. And I need to start solving this other one, so I start by subtracting x. I get negative y. Remember, this negative stays with the y. We don't add x because the x is positive, the y is negative. Equals negative x plus 2. Now I need to divide every single thing here by negative 1 to get the y truly by itself. And I get y equals positive 1x minus 2. That makes my slope 1 or 1 over 1, and my y-intercept negative 2. So now I'm going to go ahead and graph this. And you may notice that these lines will never, ever, 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 ever intersect, touch, or cross, or meet. That's because they're parallel lines. You can know they're parallel lines before you even graph because these slopes are the same and the y-intercepts are different. Remember on problem number 4, when the y-intercepts were the same as well as the slopes, then they were the same line. But when the y-intercepts are different, while the slopes are the same, the lines are parallel. These parallel lines have the same slope. And so, since the solutions where they cross, touch, or meet, and they don't do that, this is no solution. On to number 7, solving this top equation for y. I'm going to start by subtracting 3x from both sides. And I get negative 5y equals negative 3x minus 35. And I'll divide every single thing here by negative 5. And I get y to equal positive 3 over 5x plus 7. So that tells me my slope is 3 over 5, and my b is 7. So I'm going to go ahead and graph with my b. I'm going to go up 3, right 5, or down 3, left 5. And as I go to solve my next equation, I subtract 2x on each side. And I get y equals negative 2x minus 6. That tells me that my slope is negative 2, or negative 2 over 1. And my y-intercept is negative 6. So I make my b at negative 6 here, and I either go up to left 1 or down to right 1. There is no use to go down to right 1, however, because the other line it's going to intersect with is up here to the left. And then now I notice that my intersection is right here, and that is the order pair negative 5, 4. There we go. Finally, let me write it. And now, last but not least, number 8. Number 8, x equals a number, as I mentioned when I was doing problem number 5, is a vertical line. So we go to where x equals negative 2, make our vertical line there, and it's just saying x is only ever equal to negative 2. X is always equal to negative 2. The whole way. Now we have to solve our other equation. So I will do that by starting to subtract 3x because the 3x is positive. and I get negative 2y equals negative 3x minus 18. I will then divide by negative 2 to everything to get y by itself and undo multiplication, and get y equals positive 3 over 2x plus 9. That gives me a slope of 3 over 2 and a y-intercept of 9. So I'm going to go ahead and graph the b, and I can go down 3, left 2, or up 3, right 2. But going down and left is helpful since I will intersect with my other line right here and get the order pair negative 2, comma 6. And that wraps up Algebra 1, Section 6.1.